How to render curves as grease pencil strokes. Every now and then I like to experiment with curves in geometry nodes and make some cool looking motion graphics. But neither Cycles nor Evee support curves natively, so to render them out, you have to convert them to mesh first. In most cases that will do it, but depending on the curve's resolution, the mesh density might become overwhelming for your CPU. If that's okay for you, continue doing it that way. Otherwise, keep watching and learn how to render splines as grease pencil strokes. The idea is to use a simple grease pencil stroke as an instance on every segment of the curve. Add an empty grease pencil object to the scene and rename it to Outline. In the 3D view, switch to Draw mode, select the Line tool and set the subdivision level to 0. Draw a straight line and hit Enter. In the Properties panel, go to the Data tab and toggle off the Light switch. This will render a solid line regardless of any light presence in the scene. At the Material tab, set the base color of the stroke to white. Now switch to Editing mode, enable Grid Snap and place one point at the origin and the other one at 1 in the Z coordinate. Switch back to Object mode. This single stroke is what will instance along our spline. Add another object to the scene. This will represent the curve we need to render. In the Geometry node tree, I'm starting with a spiral curve, immediately followed by an Instance on Points node. The instance will be the grease pencil object I just drew. Remember to check the As Instance toggle on. Now each instance is pointing up, but we'll have them aligned to the next point on the curve. Connect an Align Euler to Vector node to the Rotate input socket of the Instance on Points node. Select Z as the axis to align. Feed a position field to the Vector input socket. Right now, all the instances are pointing away from the origin, because we're aligning the Z vector of the instances to the position vector of each point. The vector we need to align these axes on is the direction to the next point on the curve. Insert an Evaluate at Index node. Set the data type to vector and the domain to point. Feed an index field and a position vector to the value socket. To get the index of the next point on the curve, insert an Offset Points in Curve node and increase the value to 1. Now, subtracting the position vector of the next point on the curve from the position vector of the current one returns us the direction to align the instances to. Connect the result to the input socket of the Align Euler to Vector node and see the instances aligned properly. To scale them, add a Length node and connect the result to the Scale input socket. If you want to control the width of the stroke, insert a Combine XYZ vector, connect the length result to the Z input, and use a custom value to control the width of the stroke. There you have it. You can now render as many splines as you wish using this method. You could even render text outlines this way. You can also render mesh geometry edges as grease pencil strokes, but the setup is quite different. I'll show you that next. Same as earlier, we'll instance a single 1-unit stroke on all edges of our geometry. Get the grease pencil object into the node tree and remember to turn on the As Instance toggle. The Instance to Points node works with points, so in order to work with edges, we need to use the Mesh to Points and select Edges from the menu. This will position every instance on the middle of each edge. To put the strokes on top of the edges points, connect an Edge Vertices node to the position socket of Mesh to Points. I'm choosing the position field of the first point for every edge. Same as earlier, we'll use Align Euler to Vector node to align the instance towards the other point of the edge. Duplicate the Edge Vertices node and subtract position 1 from position 2 to get the direction vector to align our instance Z-axis to. It doesn't seem to work. The reason for this is that the Mesh to Points node doesn't carry this information to the instances, so they have no clue what point 1 and point 2 represent. In order to come around this obstacle, we'll need to capture this result as an edge attribute before feeding it to the vector socket of the Align to Euler node. Now the grease pencil strokes point at the other end of the edge. Add a length node to the direction vector and connect the result to the scale socket of the instance to points node. Same as earlier, you can control the width of the stroke by inserting a combine XYZ vector node. Feed the length result to the Z channel and use a value node for both X and Y channels. Now you know two methods of rendering geometry outlines with grease pencil strokes. Thank you for watching, and as always, keep experimenting and share the knowledge.